I'll be doing rates of reaction demonstrations. I'll be using water, food coloring, hydrogen peroxide, sugar cubes, vinegar, salt, yeast, and dishwashing detergent. The four factors that can affect the rate of a chemical reaction are temperature, concentration, particle size, and the use of a catalyst. The collision theory says atoms, ions, and molecules can react to form products when they collide, provided that the particles have enough kinetic energy. For demonstration 1, I'll be dissolving salt in hot water and in cold water, but first I'm starting it in cold water. Now that the salt has dissolved in the cold water completely, I'll then replace the cold water with hot and dissolve more salt in there too. So I have now removed the cold water and replaced it with hot water, and I'll be dissolving salt in there as well. So the salt in the hot water is completely dissolved now. Usually, raising the temperature speeds up a reaction, and lowering the temperature usually slows down a reaction. At higher temperatures, particles move faster. That's why the salt dissolved quicker in hot water than it did in the cold water. For demonstration number 2, I'll be dissolving granule sugar in water, and I'll be dissolving sugar cubes in water. Now I'll be dissolving granule sugar in the water. So as you can see, the granule sugar has now completely dissolved in the water. I will now dissolve a sugar cube in the water. The sugar cube is now completely dissolved in the water. The total surface area of a solid or liquid affects the rate of a reaction. The smaller the particle size, the greater the surface area is for a given mass of particles. The result of an increase in surface area is an increase in the frequency of collisions and reaction rate. In the demonstration, we saw that the granule sugar dissolved far more quickly than the sugar cube, because of the surface area of the smaller granule sugars. The smaller divided granule sugars increase the surface area, which increase the frequency of collisions. For demonstration number 3, we'll be using vinegar and baking soda. I've replaced the water with a little bit of vinegar, and I'll be pouring the baking soda into the vinegar, and we're going to observe the reaction. I am now going to put a tablespoon of baking soda in the vinegar. We're going to watch the reaction. We're going to repeat the reaction, but this time I've diluted the vinegar with some water. In demonstration 3, the concentration affects the reaction rate because the number of particles in a given volume affects the rate at which reactions occur. Cramming more particles into a fixed volume increases the concentration of reactants and thus the frequency of collision. Increased collision frequency leads to higher reaction rate. We saw the increased reaction rate when we added the water into the vinegar because we crammed more particles into a fixed volume and the reactants of the collision increased. For demonstration 4, we'll be making elephant toothpaste. This consists of yeast, a soda bottle, hydrogen peroxide, and liquid dishwashing detergent. I've added red food coloring to the hydrogen peroxide, and I'll now be adding a tablespoonful of liquid dishwasher detergent. I am now going to dissolve the dry yeast in about 3 tablespoons of warm water. I have now dissolved the yeast in the water. So now we're going to pour the yeast inside the hydrogen peroxide and dishwasher detergent mix and watch the reaction. A catalyst is a substance that increases the rate of a reaction without being used up in the reaction. Catalysts permit reactions to proceed along a lower energy path. The catalyst in this case was the yeast. When the activation energy barrier is lower, a greater fraction of reactants have the energy to form products within a given time. Activation energy is the minimum energy that colliding particles must have in order to react. As you can see, I drew a reaction progress curve for a reaction. Adding a catalyst affects the reaction progress curve and the reaction rate because to increase the rate of reaction, you need to increase the number of successful collisions. And one possible way of doing this is to provide an alternative way for the reaction to happen which has a lower activation energy. A catalyst has exactly this effect on an activation energy. A catalyst provides an alternative route for a reaction. That alternative route has a lower activation energy, also shown on this graph.